Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. Happy birthday to CoreOS. It's their second birthday, and they are the sponsor for this episode of the New Stack Analysts. And they have had quite a run over the past 2 years. They're a major player in the container ecosystem. You should check them out at CoreOS.com. Happy birthday, CoreOS. Now let's get to the show. Okay, hi, Alex Williams here of the New Stack at GopherCon, day 2. And here with Brandon Phillips, CTO and co-founder at CoreOS. Hey, Brandon.
Hey.
And here with Ian Eyberg, founder of DeferPanic.
Hey.
I was just saying to you guys that this morning there was this interesting kind of discussion about the evolution of Go and some of the decisions that were made about the programming language and how it's impacting things today. How do you see the Go programming language transitioning? How does it keep its path, or what paths do you see it possibly taking?
I think what we'll continue to see is that Go will become important as the systems language, and we're talking about systems that aren't, writing kernels, not writing underlying low-level bits that are talking directly to hardware, but systems that are interacting across a data center or across the internet. And I think a lot of the decisions that they made early on reflect that sort of heritage. I think the cool thing is it's a piece of technology that's kind of enabling a lot of interesting research and development in those areas. So you're seeing, time series databases being built. You're seeing these consistent databases being built, schedulers, things that talk to and configure network fabric. And
haven't you seen those in other programming languages, though?
You have, but I don't think that you've seen the proliferation quite as quickly. And I think it's some of the properties of the language that cause people to have a level of confidence that they're going to be able to build it and maintain that sort of those sorts of systems long term over time.
What are those properties that you think are important that need to be maintained?
With the language itself, I think one of the things that really attracted, especially people like me, to it was so simple in terms of the amount of syntax and how small the spec actually is, and that was an intentional feature, as Robert was discussing. Basically, if you take a language like Scala, for instance, Scala can be functional or it can be more procedural depending on how you use it. And so one shop might be using it functionally and another shop might be using it the other way. And if I go from one shop to the other, I get into that code base, it's going to look completely different. That's not really the same with Go. Go is very consistent, and I can go from place to place and see kind of the same style, if you will, with it.
Now, obviously, that takes time to adjust, right? If you have different shops with different kind of.
Oh yeah, and it's not just like the style, but it's also the other third-party software that those companies are using as well, because they all reflect that kind of way of doing things.
Yeah. I think that the language design decisions they made early on. I won't use the word like backwards compatible, but they were very conscious of what languages people are already comfortable with, and so you see they took features from these languages that look nothing like Go, but they took the concepts and the features and they made it look comfortable by putting it in sort of the C syntax style. And I think that was really important to language, because we've had languages and runtimes that have these properties that Go has, like concurrency and static typing. But you're right, they're a lot of times been in these syntactical styles that people are super uncomfortable with. They've been the Scalas, they've been the Erlings.
Erling's a perfect example, where you have these very small processes which are kind of akin to Go routines, But trying to do anything in Erlang looks like complete crap, and it's very hard for people who are maybe coming from other languages to kind of read and understand and grope what exactly is actually going on.
So it's that syntax.
Yeah, it sounds kind of trivial.
That's definitely a big thing for sure. So,
is that why? Does that help in terms of the speed, like you're talking about?
I think it helps in the speed of people getting comfortable with the language, because they are learning concepts. They're not necessarily learning a new way of expressing. It's like somebody who's familiar with English. They understand like the concepts of of how the sentence is laid out. But you can introduce new vocabulary over time.
Right. They understand the difference between an essay and.
That's an interesting thing too, because if you spend enough time with Go, I'm not going to say it's anti-functional, but it definitely does not lend itself to functional programming, and that has many higher order functions that maybe a beginner would not be so used to applying. So, and that was also a conscious decision on the core team's design.
So besides syntax, what other decisions were made that you think have obviously been affected that will affect the new course of Go over the next year or two?
I think the other thing that's it's good and interesting and was well thought out was having the idea of a package be something that can be externalized. So it's not just the core people on the language that are able to make decisions of what is the HTTP library, what is the whatever. You can import these external packages and bring them into the language. And I think I'm not going to speak for the core team. I've never actually asked them this, but I think over time you'll see fewer and fewer things end up in the standard library of Go, and you'll see more of things just showing up as golang.org / whatever that package is. And I think it's a conscious decision as the language has matured and as the tooling has matured to say, we can probably put less and less stuff in the standard packaging.
And then be able to then add it if you need be?
Or add it, or have somebody else write a different implementation and kind of level the field. Like the language is the language and the libraries are external.
So that wouldn't affect the compatibility at all.
That is kind of a contentious issue right now, as packaging in general has many some people might perceive them as flaws, but we're just talking about rapid third-party code, and then everything from versioning of the packages to what do you do with them, and so it's definitely plenty of room to work in that area in the next couple of years.
Rick talked through kind of the issues around generics, right? We talked about this over breakfast. We were talking about generics. What is it about generics that affects developers and has them, get a little bit contentious sometimes?
Yeah. Well, so just to point out, because it's really easy to look at Reddit and Hacker News and see this as a hot topic all the time. Not everybody actually has a problem with generics. In fact, I think a small minority of people have a problem with it. I think the people that have a problem with the lack of it is they're so used to a different style of programming from other languages that allow them to mix and match their code freely, even when it might not even be the best idea to do that. Because generally, in my experience, I've never really had to share different structures with each other. They always have a very well-defined purpose. But if you're going in willy-nilly and just throwing in code, then that's what generics allows you to do. But this is a huge problem in other languages. JavaScript has a horrible problem with it. Ruby has a horrible problem with it. I've literally seen tests where it's a test looking to see if something's a string or whether it's an integer, and it's ridiculous. So I don't see it as such a hot topic as it should be, personally.
Yeah, I don't know. It's one of those language features where it'd be nice, but engineers are very effective without the feature. So I don't know. It's for me, it's nice to have and a funny joke to bug the Go developers about. But I mean, I have no doubts that at some point we're going to get a generic.
Yeah, I agree with you on that too.
Right, but I think it's not like we're able to build really sophisticated, interesting things without it. So.
Right.
So looking back at the evolution of Go, then are there decisions early on that you find are proved, there are things maybe that they couldn't foretell that are causing some complexities or issues for developers now?
I would say the dependency management's the hardest thing for us. Like taking all these interesting libraries off the GitHub or off Bitbucket or wherever, and integrating them into a single functional package is a difficult problem, and it kind of replicates every time like CoreOS creates a new open source project. We have to bundle all those things and vendor all those things all over again. And this was primarily, I think smartly, the core Go team said we don't want to try to solve this problem right off the bat because we have no experience with it. Inside of Google, we have a single monolithic code base.
Right.
We don't import things over the internet.
Right. On their own hardware.
Right. And so it's like, to them, it's not a problem. And so they're probably the worst engineers possible to try to solve it.
Right, yeah. And there's a couple things like that in the language that, they do things very differently at Google than maybe 90% of the rest of developers do. It's not necessarily like bad versus good, it's just different. And because of that difference, you have to do things differently.
Yeah. But, I mean, the good thing is over the last year, we've gone through a number of different tools. We wrote a vendoring tool. There's been other vendoring tools that have come out. And everyone's kind of coalescing around a single set of patterns. And the Go team, the core team, is adopting those patterns into the actual mainline.
So these patterns. Tell me more about these patterns that are emerging.
Yeah. So you essentially have two ways of dealing with. I'm depending on external code. The one way is like what our Linux distros do. So if I install Debian, I'm going to install MySQL, and MySQL has dependencies XYZ going down on various libraries and security stuff. And so MySQL doesn't contain all those dependencies. It's just they depend on them externally. The other way, which is kind of what's been happening with Go, is you fully vendor them. So you actually check in whatever library you're depending on into your code base. And this vendoring pattern is what is starting to emerge as kind of the best practice here. The nice thing is it gets us it complicates the developer experience for the engineer working on the project, but it really simplifies the experience of new developers who want to get involved in the project, because I do a single Git clone off of GitHub, and I have everything I need to start building that software. I don't have to go talk to anyone else. My Go tool, some bash scripts, I have everything I need, and it means it's really easy for people to get started. And so the complexity on the core team that's working on the project, high. The complexity on new people is low. And generally that's what you kind of want in a lot of projects. You want that fast ramp up time. The other thing is that you can do perfectly hermetically sealed builds. So Go's tooling allows you to take a set of source code and run the tool over it and get a binary out that you can run on your computer, and that's reproducible. So if I have the exact same Git hash, like the exact same Git checkout, and then I run the exact same version of Go over that Git checkout, I get the exact same output every time. And that's really nice for build systems when you want to externally verify that.
Employees and
exactly. And so it has a lot of nice properties that actually make it worth the effort and the annoyance of doing this sort of vendoring.
What are some of the other patterns? Maybe more succinctly, what are some of the issues that you face with, kind of things that Brandon was describing?
Yeah, like in terms of the packaging.
Yeah.
Yeah, I think one big thing with packaging is if you are going to modify that kind of third-party package, that is kind of a pain because there's no easy way of doing that. The reflection, runtime reflection, I should specify, doesn't lend itself in the way that other languages do. And
how do other languages do it that prove effective?
Well, it's not about being effective, I guess. It's more of maybe people are used to doing it in a certain style, and so then they come to Go, and then they're like, well, how do I do this?
Yeah,
and then they discover like, oh, I gotta, maybe I have to use code generation, or maybe I have to, do something completely different. So it institutes different ways of thinking, I would say.
So is this kind of does this become an issue about the tools that are available then?
Yeah, it's primarily a tooling thing. So like you can do this all by hand. It's super painful. Right. But if we can get a rough consensus around the tooling, then it's consistent across all these different projects. And you can kind of have a consistent experience when I'm jumping between projects or when I need to update libraries across projects. That's really the thing that's most important is it'd be very unfortunate if we end up in a place where it's like 4 different tools to do this task that is very straightforward.
I think I don't know about the packaging, but there's definitely chances for other parts of the Go ecosystem to kind of splinter off too. Go Thumped is commonly touted as kind of like it was released at 1.0 and everybody uses it. Russ talked, I think, in his keynote about how they wanted everybody's code to be consistent. We just briefly touched on this as well. That's a great ideal, but I do see some kind of splintering in the future, just because people have to do things differently sometimes. And I think the tools are going to reflect that.
Now let's take a quick break before we get back to the second half of the show. Hey, this show is sponsored by CoreOS, which is celebrating its 2nd birthday here at GopherCon in Denver, Colorado. So I just want to thank them for sponsoring the new Stack. You can find them at CoreOS, CoreOS.com. Now let's get back to the show.
So tell me about the tool development process in the Go community now. How's it? Tell me, just help me and others get up to speed on where the tooling is right now, what we might need,
right?
Who are building these tools.
Mm-hmm. Right. So on the vendoring side, there's been a lot of experimentation, which has been great. We started with this thing, thirdparty.go. It had some advantages, some pretty bad disadvantages, and then Keith wrote GoDep. And that had a lot of nice advantages, and is kind of what's being roughly standardized right now in the Go tool. Dave Cheney's been working on GB, which is kind of an alternative Go build system and packaging and vendoring system. So I think the nice thing is that the community has taken up the challenge and experimented a lot, and we've learned a lot of lessons on what works and what doesn't work in this sort of complicated user experience and technical challenge of building these tools. So on the vendoring side, there's been a lot of experimentation. I think the other thing that Go, just as tooling is concerned, has a huge advantage is we have extremely smart people building extremely difficult things. We had talked today about the Go Fuzz thing that generates generational fuzzing of inputs to systems.
What does that do?
So you can find bugs. So people write unit tests, but people are really uncreative about what inputs will actually end up inside of a computer system. And so this tool, say you have something that takes a string. Well, a normal human writing a unit test would try an empty string and then maybe hello, and then all right, I think I covered everything. This thing's going to generate random hex characters. It's going to generate things that are non-printing characters. Try to run it through your program and see if it crashes. So we have people just building really amazing, difficult tooling inside of the platform. The tracing stuff inside of Go is really great, the coverage stuff. And these are things that a lot of languages take much longer. I've seen much longer time cycles.
That's the other thing I keep coming back to is Go hasn't turned 6 yet since it was publicly released. And, comparing it to something like Java, which is 20 years old. And that's why I believe Go is going to eventually overtake Java in the next couple of years, is simply because we're on a growth path that's much, much faster than the JVM is.
Do you think that's true?
I don't know about JVM competitiveness, but I think the developer tooling makes it extremely attractive to build these sorts of systems. Because it's okay to make a language that compiles and runs. But the difficult part is the moment that you have to be like, well, what happens in this particular scenario? I want to trace through this execution path. How much coverage is my code actually getting through these tests? And these sorts of things are actually difficult engineering problems in of themselves. And a lot of interesting languages skip over them initially. And Go, I think, has had this strong concentration on what is the developer experience and can the developer actually fully understand their system from beginning to end, particularly when you're building systems as complex as people are building Go systems, like these databases and these load balancers and these schedulers. If you don't understand all the performance trade-offs and all the inputs and outputs of the system, and you can't visualize those on a graph, and you can't dump them to a file for analysis, you really haven't really built anything at all. It requires those things.
Right. So the tools have to be all-encompassing. That's part of the deep complexity, isn't it?
Yeah. It's not just about taking source code and generating machine code. It's
right.
about taking source code, generating machine code, and then being able to understand what the machine's now doing,
That's pretty sophisticated.
Yeah.
Are there platforms needed to help build those tools? Because you can't just have a few people developing those tools.
Well, I mean, a few people is quite a few tens of thousands of developers.
Well, I mean, okay, in terms of the people actually have the knowledge of building these end tools.
Well, that's a good point, because there's definitely, it's definitely skewed towards a small portion of people at that time. I think probably half the people I've talked to in the conference, at least half of them aren't even using Go in their companies today. They're coming here trying to learn and trying to maybe put it into their companies. And so there's definitely still kind of like this, a group of kind of all the hardcore Go developers, and then those that are interested in as we learn. So
right.
And on the tooling side, I think the huge advantage that Go has is that unlike the Pythons or the Javas, there's nothing that you install on your servers in order to get a Go binary running. You compile that code, and it's a static binary. It has zero dependencies on the host system. And this is the reason why you see these folks that aren't necessarily Go experts are interested in it, but they know that they can kind of sneak Go into their infrastructure. They have this hard problem. They need some sort of concurrency, or they need some sort of like server component, microservice, something, and they can kind of sneak it in there. They can just have it run through the compilation step, and then just copy it over the server and run it.
As I've spent a lot of time talking to people who do DevOps type of work,
right?
And I think DevOps really they grabbed on to Go specifically for that reason, because if you look at other ops tools like maybe Chef or Puppet, something like that, the very first thing you're going to do if you want to use that is you have to go apt-get install Ruby or apt-get install Python, and then it's like, oh, well, this uses the C library that I need to go install, and then, oh, I need to go install this, and then you've just exposed yourself to like 20 different things. We just had another OpenSSL vulnerability today released, so these are actual real problems that people have. And so having that single static binary, most of our systems are AMD 64. They output dwarf, and it's an ELF binary, and so that's all you need, and that's really great about Go. So
yeah. So it's because of the standard library and how rich it is, and then the fact that the team took the time to think through, not relying on C as a crutch to do hard problems. Like TLS security is a hard problem, and nearly every other language says, I'll just import OpenSSL, this C library that's very common for doing this TLS stuff. The Go team said, we're just going to implement TLS ourselves. We're going to go off and we're going to implement TLS purely in Go in a type-safe system that has a lot of memory safety properties. And so there's no shying away from extremely difficult problems on the Go team. Mm-hmm. And what that translates to is these very, very nice properties that seem so straightforward and obvious, but it requires significant amounts of engineering effort to get there.
So what are going to be, do you think, some of the tough decisions that are going to have to be made to keep Go, running in this very, right, with such rapid acceleration in the community?
Mm-hmm.
Yeah, I mean, there's definitely definitely some compromises will probably have to be made in the future.
Such as?
Obviously we talked about the generics thing. I don't know if that will actually happen with the main Go compiler. Maybe another one. I do kind of see different dialects, no matter how much the core team doesn't like that idea. I do kind of see that happening. In fact, I've already seen examples out in the wild. I think it does come back to, over at Google, they developed it because they thought, oh, this is going to be with systems programming. But we've seen all this influx of many other types of programming work that needs to be done, especially like all the web apps. Many companies in, say, San Francisco, all the Node.js shops, all the Ruby shops, a lot of the Scala shops, I mean, they've been slowly moving over towards Go. And so I think that's a component that maybe they didn't realize how big that portion was going to actually be. So,
yeah. I mean, the big challenge too is, I talked about this static binary thing being attractive as like a tooling thing. It's very easy to take something and deploy it. The downside, the hard part, is that updates become very difficult.
Right.
Because as good as I'm sure the Go TLS implementation is, or the Go implementation of HTTP or whatever, there's going to be bugs. And as people kind of think of Go as this way of taking source code and just transferring it into this binary, it also means that you have no idea are these binaries that are running on my servers exploitable to the various issues that are inevitably going to come out of the standard library. And so a big challenge over time is going to be how do we manage the complexity of the updates to these underlying systems that we're building in Go? How do we audit them? How do we make sure that they're actually using the right versions of the standard library, they're patched?
Shared libraries is a perfect example. That was, for the longest time, shunned for very good reasons. But that brings up a thing. If you have some sysadmin and he wants to go in and patch everything, in this case, you would probably have to go ahead and redeploy a new binary to your servers. So it's little tiny things, and that support for that's already coming. You had to have this support for Android just because of the way Android works. I think we're going to see more support for that in the future. So that's definitely a compromise that they've started being more lenient with.
The core team and the complexities that they face. Tell me, I mean, I really know very little about those complexities. What are those complexities?
I think one of them's not even technical. One of them's now that they kind of unleashed, the monster upon the masses. Now they're having to deal with the masses. So it's like, the whole community thing is kind of a big hot topic right now because there's many people with differences and learning how to kind of respond to people in an appropriate manner. I mean, like Russ admitted on front stage that, sometimes when he's busy coding, he'll be like, the equivalent of like screw off or something, which people obviously might take offense to. I'm guilty of doing that a lot myself. And, it's just something that you have to realize that not everybody is in the exact same position as you are. And so it's just like accommodating the wider community to get to the point to where Go can grow to its full potential. Because if it's just like this quote unquote systems language that only the Google guys use, then nobody else will use it. So I think that's like one of the big challenges actually that's non-technical.
We're at the convention center, so we're having one of these
So like a door stuck?
Yeah.
Pause it.
Okay. All right.
Like
that's the beauty of editing.
At least it's a nice even signal through the band, right?
So you're talking about that all those complexities that come with dealing with a big community,
Right.
has started to show that that's something that they're trying to learn a little bit better. I mean, how is that being manifested? How are you starting to see that manifest at all?
Yeah, I think it's just it's a result of something that's growing quickly, right?
Yeah.
When you have
Right.
a small group of people that trust each other, so when somebody does have a bad day and they say something like mean in a comment, there's that trust that, oh, I know he's not saying something mean to me. He's saying something mean because he's just like in a place where he's just trying to get some work done and I interrupted him. And so like it's just being conscientious, and people, like a lot of engineers, they will start off in a spot where they're not working with other people, and then suddenly whatever they're working on becomes extremely popular. Now they're in a place where they have to work with a lot of people.
But
Right.
does this surface out of kind of core issues that the community is having and trying to answer them, get answered, and then that communication becomes a factor?
It's just moving from implicit trust to explicit trust, and you do things of explicit trust by like writing down a code of conduct, by telling people what is the expected behavior inside the community. And so that's the transition that a lot of people make when they move through open source, and when a set of engineers grows from 20 people to thousands.
Yeah, I guess I was thinking about like how, like, when communities start to grow, it's, problems start to surface, right? And then there's different camps, and, people have different frames of reference, and they have different contexts. And,
Right.
I guess that's kind of what I'm wondering is like, are these issues, because often when you see like people, maybe acting in a rude manner, it comes out of that, right? Because they can't find ways to communicate on topics, right?
Well, the other thing though is like we're
just curious what those topics are,
we're talking
too.
about the internet, and we're talking
Yeah.
about geeks using the internet.
Yeah.
And so those two things, sometimes they don't lead to the best circumstances to begin with, because you're behind a computer. It's not like we're talking face to face. People act very, very differently when they're just at a keyboard. And there's a large portion of developers that are introverted by nature, and so that doesn't really help anything out either.
So as Go becomes more widely accepted and the community continues to grow, how is this core team going to be able to manage that the complexities that are already quite extraordinary?
It's fair. I think something they've done really well is being very explicit about what the next set of goals are for each release. And so that's kind of what you have to do as the community grows, is you have to be explicit. What is it that we're trying to accomplish in the next few months? And the explicitness drives the ability to say and manage expectations. You can tell somebody, look, this is super interesting what you're doing. We can't even start thinking or talking about it for the next few months.
Like Rick had fixed the GC problem with the new GC stuff coming in 1.5, but it was too late, and he was told, no, can't. You're going to have to wait until 1.6 for this fix, even though it's a very valid fix and it solved the problem. And so it's and he's on that team. So
Yeah.
But the other thing is I think there's real contention between developers that are used to certain features of other languages. They come to Go, they don't understand why decisions were made, and then they get offended because they're basically told to go screw themselves. I think people feel that a lot on the mailing list, because the mailing list especially, somebody will ask a question, well, why not this feature? And mostly I think people are tired of answering the exact same question over and over and over again. And so you'll immediately get like 10 replies being like, this doesn't work, and like, almost in a condescending tone. And I think that's kind of like one of those things that has been really kind of pushing that whole community.
So
discussion.
a tough job of the core team really is to set those goals.
Mm-hmm.
And because those goals might possibly, might seem like they're like not difficult, but we all know what happens when you make that assumption, right?
Mm-hmm.
So have they been, do you see them making those decisions that are so they can do less and be more effective? Are they doing a pretty decent job of it. It seems so.
Yeah, I think they've been doing a really good job. Like they have a tendency to understand well what they can legitimately get done in the 6-month cycles,
Right.
And they have a good idea of the things that they'd rather the community sort out on their own, like this vendoring stuff. And so I think that they've been doing. They get an A in my book.
Yeah, me too. I mean,
who is the core team?
It's kind of a mixture of people that are from the original Google team that started the project. There's been people from other companies that have gotten involved. Like I've seen a lot of names from Intel and
it's kind of hard to, quantify what exactly a core team would be. Anyways,
that's true.
I mean, do you get one line patch in the main repo? Are you part of the quote unquote core, or are you like Dimitri who files 20 bugs a day? It's like So.
It's not. Yeah, that's a good point. It's not a super explicit set of people,
right?
Because people come and flow, come in and out of the flow.
I think that's probably a good place to start. Thank you guys very much for for joining us on the new Stack Analyst show.
For sure.
Cool.
Thanks for having us.
Yeah, thanks.
That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor, CoreOS, the first influential micro-operating system in the market. And they have had quite a run over the past 2 years. They're a major player in the container ecosystem. Happy birthday, CoreOS, which is celebrating its 2nd birthday this week at GopherCon in Denver, Colorado. Woo! And they are the sponsor for this episode of the New Stack Analysts. You should check them out at CoreOS.com. Happy birthday, CoreOS. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again, and hope to see you back at the show. Bye-bye.